Okay, good morning. Welcome to the first video entry in regards to the Torque 3D software engine. I'm going to start off um, possibly in the graphics subsection of the engine itself. So that's going to be the name of your project, DLL, and then it's going to be source files, engine, GFX. I'm starting here because this is the only part of the engine that is documented in the official documentation, and poorly at that, might I add. Hopefully this video series can work personally for me, or I guess anybody else who watches this for whatever reason in the future. A beginner's introduction to this engine. Now this engine is MIT licensed now, so it's always going to be open source from here on going forward. It's useful. It supports 3D and whatnot in a very kind of intuitive way. There, I'm going to go ahead and launch the engine. Enter the world editor. The world editor is actually in the game itself in this game, or in this engine. You can actually spawn it directly from script if you want. But yeah, you can see that. Boom, 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 boom. Engine, pretty simple. I'm sorry, hold on. The editor, pretty simple. Let's go environment. Let's go basic sun. Great, new. There you can see the custom sun. Kinda cool, huh? Then let's say you wanted to add some cloud cover. Whoops. Custom clouds. Create new. There you go. You see the clouds up in the sky. Pretty cool. Dark sky, kind of like a Martian landscape. Then you can do cool stuff like adding terrain. You want to add new terrain? Yes. Let's go spooky terrain. It's 512. Let's add some noise to it. Let's do rock dust. And there you go. You can see that the terrain has actually been generated in game. Not sure why it's rendering so terribly. But if you don't want like a flat ground for it, you can go and scene ground plane. Oops. Whoops. Alright, exited the editor. You can re-enter the editor by pressing F11 if you want. But yeah, if I remove the ground, you can see now we have like some crazy valleys and stuff. But you can see why this editor is interesting as a developer, because you can create all sorts of, you know, interesting virtual worlds if you're into that sort of thing. And with the advent of the Oculus Rift and a lot of other technologies that are emerging right now, it's simply silly to not familiarize yourself with this sort of development. I mean, not if you want to be part of any sort of a future development paradigm. So I'm going to close this editor since it's very unnecessary for me to have it open since it's a source code overview. But some of the concepts I'm going to be going over in this are pretty relevant. Because we're debugging this in Microsoft Windows Visual Studio, debugging is very, very simple. Like the application is running right now. Actually did start it in the debugger. You can see the output here, symbols, locals, watch, etc. The application actually is started. If you're familiar with doing any debugging in Visual Studio, like you'll understand how this is useful to us. We can go down to, where is it? I forget where the, okay, app. In the engine, app is where the main application loop is. So we can go down here. Here you can see the main application loop. do main loop. If I set a breakpoint here, hold on, let's no, that didn't hit the breakpoint. Hold on. That's almost embarrassing. Oh, neat. Zoom. Hold on. Oh, duh. See, I hit that right there. It was because I had the breakpoint inside of this loop that it didn't break. But here you can see the breakpoint. Bool keep running true. You can see the application is halted. It's not actually running. If I remove the breakpoint, hit continue, application keeps running. This will be invaluable for us in terms of understanding the application itself. By being able to do this, like, we really don't need a whole lot of documentation, as we can walk through the process quite step by step. So at this point, I've illuminated. Sorry, pronunciation error. I've eliminated the fact that the main loop exists in the main loop file, which is in the app engine. The engine app directory. Excuse me, I have a sore throat. But we're not focusing on this. The main loop, what we want to take out of this potential piece of code here is that there is an event loop. If you're familiar with any event-driven programming, this is where the event loop is. I think, at least. Hold on. Where is it? Every time there's a frame in the game, this will actually run. So if I put a breakpoint here again, see it stopped. If I actually bring Torque 3D back up, hold on. Continue. If the game would actually show right now, it's not actually coming up on the window. You would actually see the frames being iterated, because every single time there is a frame, this loop is called. So I don't know if you can see with the low frame rate on the video, but I'm clicking rapidly here in order to just show how it just continuously loops. So here you can see process events. Now I'm learning this engine, but as far as my understanding right now, from a developer's perspective, my understanding is that this is where event handling is done. This is the base of where event handling is started. Now, events are how the engine works. Like, events and signals are basically how everything ties together. There's this main loop running, and every time something is processed, in terms of event-driven programming, these events are sent to objects, and these objects can act on them in any variety of ways. So let's say there's a shader object or a render object. Well, if you had an event that was tied to them, like a registered event that was tied to them, you could have them react dynamically in game, or in the 3D world. It doesn't have to be a game. I'm not sure exactly that is what is happening, but I'm confident enough to put it on video. I'm learning this anyway. Okay, so process main thread work items. I think this is just like, because this is the main thread right here. It's just gonna, like, there are certain things that need to be done in the main thread, I think, and this is where it's done. Here you can see begin frame, and here you can see end frame. After this is called, like, the frame will render on the screen. Like, I wish Torque 3D would show up in its normal state. I think I had it maximized in the background when I did it last time, and I hit this continue loop over and over, and you could see, like, the actual textures changing one by one. So I'm gonna set the breakpoint here. I'm gonna remove this. I'm gonna go ahead and hit continue. Oh, excuse me. Told you I'm kind of. Oh no. Yeah, I told you I'm kind of under the weather. So we stopped here. I'm gonna step into this. You can step over something in a debugger if you're familiar with debugging. Like if you step into, it'll actually follow execution into this function. If I press step over, it'll execute that function, do all the work required inside of that function. It'll return however many times it needs to return back to the position after executing this line, and then it'll continue to the next line with all the data filled out from whatever this does. So I'm gonna step over now so you kind of understand. See how it went from here to here? Well, that means it did all of the work involved here, like every bit of work that was involved inside of there, and it's done with it, and it's here in the end frame. So, oh, excuse me, man, I don't feel good. So anyway, we're not going to analyze begin frame and end frame yet. We are going to analyze process main thread work items though. So I'm going to continue it because we know it's a loop. It'll do all the code required to get back to this position again. So continue. See, it went down, executed everything it needed to, went back up to the top, came down, and stopped where we were before. Now, last time we stepped over, this time we're going to step into. So what we're going to see when we step into is the thread pool main process main thread work items method. Here we go. Oops, I went over again. Continue. Okay, so let's go step into. See, there's the method. Assert fatal thread manager is main thread. Thread pool, this function must only be called in the main thread. Okay, yeah, that was what I was assuming based on the name of the function. So, where is it? This is all done in the main thread. And these are the... Oh, whoops. Where'd it go? Oh, here we go. Yeah, this is the stuff that needs to get done. Threadpool.cpp. So let's look at open containing folder. Where's this? Okay, source platform threads. Platform threads. Okay, so in regards to this, I'm assuming there's a thread abstraction, like just an abstraction layer that allows for threads to be used in a really multi-platform way. I mean, that's the whole reason for the abstractions. This engine compiles on Linux, it compiles on Windows, it compiles, you know, all over the place. So there has to be abstraction layers for that kind of stuff. So I'm assuming this is the abstraction layer. So here we go, time limit, and get real milliseconds plus get main thread threshold time milliseconds. Gonna look at this. Threshold is 0 milliseconds. Weird. We'll go back. So, okay, so the time limit is huge. Get real milliseconds. Hold on, let's see what that is. Dword when API void. Okay, get declaration. Oh, it's a Windows API function. I'm sorry. I think. Hold on. Maybe not. Yeah, it's a Windows API function. Okay, so let's close that. Go back there. Hold on, let's go step. work item. Let's look at what work item looks like. Sorry, I'm trying to understand this. So this is overridden, this is overridden. Process the work item. Execute. Should be thread pool. See, I'm not sure exactly what this is doing. It's calling execute, but is execute defined? Oh, so it's just overridden. So when yeah, sorry. Whenever this is overridden, it's basically overridden with a routine that I guess is defined by whoever wants to define it, like in terms of development. Like if somebody wanted to create like a work item, they would just create a work item, and this is where they would override the actual work that they wanted to get done. They would override this with the work that they wanted to get done, I think. Process the work item. Cancellation requested, get priority. So I guess they're named mainly for debugging. Okay, so num threads, number of worker threads spawned by the pool, number of threads awake, number of threads ready. Here's a semaphore. Okay, so those are all the private methods. Now here's the public methods. So create thread pool, number of threads. So I guess this kills all threads. Pretty sure this is not something you're supposed to do normally. You're supposed to wait for them to die, but you know what, I guess this is where you should have known. So this looks to be defined. Let's see how. Worker thread. So this is the function that actually does the processing. This is the worker thread function. Okay. Or the worker thread class, not function. Okay, let's spend a little bit of time reading this. Process work items waiting in the main threads. Work queue. Get queue update interval. Okay, so as we can see, this right here, which is where we were looking, a real simple thread interface. I'm not sure exactly how to use it. I guess you just call the constructor and then work from there. Worker thread. Where's the constructor on this? Did I miss it? Oh, here we go. So this is what you do. You call the constructor, you call the number of threads, and then from there you can manipulate things. Sorry, I didn't see that from the start. So structure definitions. Global thread pool. So I guess this utilizes the global thread pool. I'm not sure how it's implemented though. I love reading this code, by the way. Like, I've never had a reason to learn a 3D engine before this, so it's kind of neat. But okay, so as you remember, we are in the debugger. So we are here right now. Thread safe reference. Step into. Oop. Okay, so this is the work items. If you remember from the main loop.cpp, we started off here, process main thread work items. Well, that's where we ended up. Hold on, is there a forward? No. Okay, so this is where we are right now. Work item, wrapper item. Okay, so this right here, I'm guessing generates a statically set threshold. I'm guessing. Hold on, let me look at this. Go to definition. So is it just never set? Is it always 0? I mean, this is what we're looking at for time limit, so it's just get real milliseconds. Sorry, I'm tracing this. Okay, so there's not a next. Let's set a breakpoint here. Let's wait for the item to actually process. So there has to be. I'm removing the breakpoint that was here. I'm sorry, before, and I'm actually setting a breakpoint here to see when something actually comes through. So I'm just going to hit continue. I'm going to remove this, and I'm going to continue. So the application is running now. It'll only stop in the case that I guess there is something that needs to be processed. Huh. Maybe if I go down to F11. I have no idea what's going on here. Can't wait till this makes sense. Okay, so the main loop. Shouldn't. Sorry, I just reloaded a blank one. So, I wonder how many main thread work items. I'm assuming the game engine runs off of a variety of thread loops. Okay, I'm going to search. I want to find torque main. I think that's what it's called. It's just the entry point for the application, because I'm a little lost here. I'm sure you're probably lost too. Source main CPP. Okay, so when you create a Torque project, a Torque 3D project, it creates two entries: test project, no physics. I'm sorry, it creates the actual name of the project itself and the name of the project DLL. So project DLL, the project itself, which is what you're seeing here, main.cpp, this depends on the DLL in order to run. So everything that is important in regards to your application is started via this DLL entry point, which is torque win main. So here you can see it loads the library. This is the actual DLL itself. It gets the process, or I'm sorry, the not process, but the procedure address torque win main from HGame. Now all this is doing is just extracting, not extracting. It's looking through the export table in the library, finding the function named torque win main, and then it's just gonna go ahead and launch it, I'm guessing. So here's the handle. It's just basically saying, okay, if there is a win main, go ahead and skip this, but if there isn't, go ahead and report an error. This is that condition for the library. This is that condition for the export within the library. So if it opens a library and it can't find torque win main, it does this. If it can't open the library at all, it does this. Here you can see that since torque win main was assigned here, like you can actually call it as a function using h instance, prev instance, command line, and command show. I'm not sure. Hold on, what are those? Oh, those are just sorry, it's been a while since I've been in Windows. Those are just the function parameters for win main. So win main and torque win main, identical basically. All it's doing is passing this to this. So I guess if you wanted to, before the engine even starts, you can have a bunch of code run here. You can maybe set up an environment or something. I would think that would be a bad idea because it's more important to have the engine load. But still, that's something you could do. So torque win main is what we want, and torque win main should exist in here. So let's go down to let's go ahead and search. Where is it? Edit, find and replace, find in files. Yes. Find all. Torque 3D engine source main.cpp. Okay, so engine source. Torque 3D engine source. One second. Sorry, I opened this in a different window. I should have kept this here. All I'm doing is I went to Torque 3D engine source main. I want to see what this actually looks like. Okay, it opened Qt editor for whatever reason. Let me close this. Actually, I'm gonna conclude this video at this point. Nature calls, so I will return.